Let's have a look at this question. This is a very standard question that you will get in this topic. So the heat of combustion of propan-2O, in formula is given, was investigated using the equipment shown in the diagram below. And this is identical to the experiment that we did. So you have a spirit burner with the fuel inside, and then you heat it up, and then you measure the change in temperature of water. Except that the thermometer shouldn't touch the bottom of the can, so that this is poor form. And they're using a metal can instead of a glass one. So 1.29 grams of the fuel was used and it was burned in the spirit burner to heat 200 grams of water. So the fuel is here, 1.29 grams, and the water is here, 200 grams. The temperature increase of water is 37.6 degrees Celsius, and you need to use this information to calculate the molar heat of combustion of propan-2O. The unit is specified here, kilojoules per mole. Okay, I don't have enough space here, so I'm going to summarize the question on the next slide. So the mass of propan-2O, C3H10O, is 1.29 grams. The mass of water that was used is 200 grams. And the change in temperature of water is 37.6 degrees Celsius. So you need to determine the molar heat of combustion of the fuel. So you need to find molar heat of combustion in kilojoules per mole. So very specific unit here. You cannot leave your answer in any other unit to get if you want to get full marks. This is a very generic question, as I mentioned already. So all you need to do, step one, is you want to find the energy absorbed by water. If you ever need to find energy absorbed by water, that's a signal that you can use mc delta T, because that value allows you to determine energy absorbed or extracted from water. So mc delta T. This is the first common mistake that students tend to make in this topic, is that they use the wrong mass. So if more than one mass is given, people just don't use the correct one. So just make sure that if you're finding a value for water, that you actually use the mass of water and not of the fuel, which I've seen like once a year at least. So 200 grams and 37.6 is going to be delta T. So we're just going to do the calculation here, and 200 times 4.18 times 37.6 should give you 31,433.6. And this is a second mistake that I see every year, is that people get the unit of energy here wrong. Now, specific heat capacity is reported in joules, so the energy absorbed by water should be in joules. Since your final answer is supposed to be in kilojoules, now is a good time. I mean, you can do it later, but I'm just going to do it now. I'm going to convert the energy from joules to kilojoules. So 31.4336, all you need to do is divide by 1,000. Okay, so this is the energy absorbed by water. So essentially, if you think about the setup, some of the energy released by the fuel is going to be absorbed by water, and we know exactly how much was absorbed. And the main assumption that we're making in this setup is that we assume that the energy released from the fuel is the same as the energy absorbed by water. So we have to assume that the energy released from fuel is also 31.4336 kilojoules. There is a situation when you don't make this assumption, if I give you some extra information on percentage heat loss and all that, but in this case, with the information given, I have to make this assumption. So I basically know now that if I burn 1.29 grams of propan-2O, this is the amount of energy that's released, and you need to find the heat of combustion. So in order to do that, you just need to work out how many mole is in 1.29 grams. So the molar mass of propan-2O is something. So 3 times 12 plus 10 plus 16. So I get 62. Let's hope that's correct. Grams per mole. So this is the molar mass of propane, and then from there I can work out the number of mole of 1.29 grams of the fuel, which is the amount that was used in the reaction. So 1.29 over 62. You know, whenever I do this and I record, I have a strong suspicion that all my calculations are wrong. So 0.0208 mole. We're going to use exact value. Let's just leave it at that. And then, so basically what it means is that if you burn 0.0208 mole of fuel, you will get 31.4336 kilojoules of energy released, and you need to work out how much energy is released per 1 mole. So just one divided by the other. Okay, I'm just gonna try to get exact value. So 1510.8 kilojoules is the amount of energy released from the combustion of 1 mole of propane-2O. Let's go back to the question. We're looking at 3 significant figures, so final answer is going to be 1.51 times 10 to the 3 kilojoules per mole. So that's a molar heat of combustion. Once again, we're looking at heat, not enthalpy, so you don't need a negative number. And that is it for question 2.